this video we're going to look at the structure of an atom, okay? And to work out the structure of a particular atom, we need to understand the mass number and the atomic number, okay? And these are the numbers that you find on the periodic table, which you get in the exam, so you don't have to worry about remembering this data. You will always receive a copy of the periodic table in your exam, okay? So if we look at the bottom number, okay, the bottom number is the atomic number, and it's sometimes referred to as the proton number as well, okay? And the top number is the mass number, okay? So from these two pieces of information, we can actually work out how many protons, neutrons and electrons there is in any atom for any element on the periodic table. So what information do we get from that? Well, the atomic number equals the number of protons, which also equals the number of electrons. So the number of protons and electrons are always the same in an atom, okay? And you get that from the atomic number. So what information do we get from the mass number? Well, the mass number is the number of protons and neutrons in the nucleus, okay? So that means it tells you how many things are in the nucleus. So how do we work out from that what the number of neutrons are, okay? Well, we work that out by the number of neutrons equals the mass number minus the atomic number. Now that's because if we know how many things there are in the nucleus, in other words, how many protons and neutrons, and if we know how many of them are protons, well, the remainder of them must be neutrons. So that's why to work out the number of neutrons, we get the mass number and we subtract the atomic number. So let's work through an example on this. If we look at sodium, okay, here's sodium, its atomic number 11, its mass number is 23. So how can we use this information to work out the number of protons, electrons and neutrons? So we're going to use the first rule, which tells us that the atomic number, the bottom number, equals the number of protons and also equals the number of electrons. So the number of protons is going to be 11, and also the number of electrons are going to be 11. Now the mass number is 23, okay? And to work out the number of neutrons, we get the mass number and we subtract the atomic number. So when we get 23 and we take away 11, that's going to give us 12 neutrons, okay? So how are these subatomic particles arranged in an atom? Well, we know that the protons, neutrons and electrons, okay, are arranged in different ways. The protons and the neutrons are in the nucleus, okay, and that's where most of the density comes from atom, okay. So most of the matter is in the centre. Obviously this is not to scale, okay. So you've got the protons and neutrons in the middle, and you have the electrons orbiting around the nucleus in shells, okay. So all the protons and neutrons are in the nucleus, which is in the centre, and the electrons are orbiting around that. So how are the electrons arranged? Well, these electrons hang out in shells, and the first shell, which is the shell closest to the nucleus, can hold a maximum of 2 electrons. And for GCSE purposes, all the other shells can hold 8 electrons, okay? So the first shell, which is the closest one, holds 2, then the next one holds 8, and so on and so on, okay? And it's always the first shell that fills up first, and you won't start putting electrons in the second shell until the first one is full. So let's show you an example of that. So if we look at sodium again, sodium has 11 protons. So if you look, and so it means it has 11 electrons as well, sorry, okay? So how do we arrange these electrons? Well, we just follow the rules that we talked about in the previous slide. The first shell can hold 2 electrons. So we put our 2 electrons here, which is what we've represented with these crosses. We put them in. But we've still got another 9 electrons to put in. So we can put 8 in the next shell. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So altogether now we've put 10 electrons in. We want to put 11, so then we've got 1 electron left in this third shell, and that's what we put there. I hope you found this video helpful. Thank you.